So consider this given problem statement. So suppose U is the power set of this given set S containing the elements 1, 2, 3, 4, 5, 6. So for any set T that belongs to U, so here this particular representation denote the number of elements present in set T, and this T dash denote the complement of set T. So for any set T and R that belongs to U, so here let T slash R be the set of all elements in T which are not in set R. So this essentially representing T minus R, that is the subtraction operation among sets, right? Now which of the following statement is or are true? So let us go to each option one by one. So first of all, we'll go to this option A. So we can clearly observe in option A it is mentioned that for all x that belongs to U, the cardinality of x is equal to cardinality of x complement. So first of all, let's just mention that what all information is given to us. First of all, this set S is given to us with the elements 1 to 6, right? Next, here U is the power set of S, right? So U is representing here the power set of S, correct. Now, and T complement, and then we are having T minus R. So these are the given information. Now, based on this, we'll analyze these options, right? So here I have written the first option. Now for this one, we can take some example, right? So let us consider that set A is containing the element 1 comma 2. So in that case, we can clearly observe that x complement. So if I just consider for this A as x, so in that case, the x complement will be 3, 4, 5, and 6, right? So from this, we can clearly mention that the cardinality of x will be equal to 2. And from this, we can say that the cardinality of x complement is again 4 over here, right? Now from this we can say that option A is false. Now next we'll talk about option B. So I'll write here option B. So here it is given here, there exists x which belongs to the set U, and there exists y that again belongs to the set U. So here the cardinality of x is mentioned 5, as well as for the cardinality of y here, right? Now we can clearly state this thing, that any two possible subsets of this set S with five elements must have at least four elements in common, right? So this is from the pigeonhole principle of counting, right? So hence we can say that x intersection y, this is not equal to 5. That is the empty set, right? The empty set representation. So from this we can conclude that statement B is false. Now next, let us go to this option C. Now here, for this option C, it is mentioned here, for all x that belongs to set U and for all y that belongs to set U. So here the cardinality of x and the cardinality of y will be equal to 3. So let us check this part. Now here we can clearly observe that set x and set y can have any number of any number of elements from 0 to 5. So like a set can have 0 element or 1 element or 3 and so on up to 5, right? So even for the given constraint, so if I consider the constraint, let's say something like this, x containing the element 1 comma 2, let's say x containing the element, let's say 1 2, and then let us consider that y containing the elements, let's say 3 4 5, 3 4 and 5. So from this we can observe clearly, that x and slash y, so this is equal to 1 comma 2, right? And this is not equal to, the empty set, right? This is non-empty set. So this is non-empty set. So from this we can mention that statement C is false, right? Now we'll analyze this particular option D. Now let us check for this option D. So for all x belonging to set U, that is universal set, and here for all y U, so here x slash y is equal to y complement slash x, right? So we can just consider the example, let's say. So here set S is given to us. I'll take this particular set, right? And then for x I will consider the elements, let's say 1 2 3. So we can also prove this in analytical form, but just to solve it quickly, I'm just considering some example here, that is x as 1 2 3 and y as 2 comma 4. So from this we can observe that x slash y, so according to the definition we can say this will be 1 comma 3. And if you observe from this given set, y complement can be written as 1 3 5 and 6, and x complement can be written as 4 5 6, 4 5 and 6, right? So from here we can mention that is y complement. I'll just take this factor, y complement minus x complement. This will be equal to 1 comma 3. So from this we can clearly observe that statement D is true, right? So we can also take it this way, that we can use the set identities, and considering some basic set identities we can prove this particular statement. So for this given problem statement, only D is the correct option. So I hope it is clear to everyone.